Well, what happens now if we add a second ISP here? Now we're going to add Barry's ISP. We go out and request some quotes for redundant internet service providers. We find out that Barry is our next best bet here for internet service, and we contract with Barry's ISP to provide internet. Well, what happens here is the way that IPv4 addresses are handed out is TCAP's ISP has to ask an Internet Numbers Registry, in this case ARIN in the United States, ARIN, and he has to ask that organization for blocks of IPv4 space. And then what TCAP's ISP would do is carve up that IPv4 space that he received and then hand it out to the customers of TCAP's ISP. So here 2030.113.88/29 is owned by TCAP's ISP, and then Miles Master Editing will then contract with TCAP to provide that IPv4 address space as that /29 network. Now Barry's ISP is not going to have the same IP space that TCAP's ISP is going to have. So here Barry's ISP 198.110.0/28 is going to be the IP space that we get from Barry's ISP. Now that causes somewhat of a problem for us for some situations. Let's take a look. First off, if we are on the inside of our network trying to reach the outside, we can have network address translation running on our routers, and that way we can maybe use TCAP's ISP as our primary link to the internet, and then should that router connecting us to TCAP go down, we can then send our traffic out of our network through our other connection to Barry's ISP. Now we can just use routing policies within Miles Master Editing organization to determine which router we use to get out to the internet, and that'll determine which NATed address we use. Here the router on the top is going to use TCAP's IP space, the router on the bottom is going to use Barry's ISP's IP space. Now the difference happens when we're trying to connect from out on the internet. When I'm a user out on the internet, my web server has an IP address in Miles Master Editing of 2030.113.90. And what that means is that the only path to get to my web server is to go exclusively through TCAP's ISP. If Miles's router goes down, the one that connects Miles Master Editing to TCAP's ISP, when we send that message to reach our web server on 2030.113.90, the internet no longer has a path to get to that network, and we throw the message away, which means that our users out on the internet that are trying to reach the website are unable to contact the website should one of the connections to one of the ISPs go down. So what we have to do instead is we have to come up with different IP space and a different way to do this. Now, just like TCAP's ISP or Barry's ISP can go to ARIN and request IPv4 space, so can Miles Master Editing. Now, that IP space is hard to come by. However, it is possible to go ask for that IP space. And in this case, let's say that Miles Master Editing goes and asks ARIN for some IP space, and they're able to purchase directly from ARIN 2030.113.16/29. In addition to purchasing that IP space, we'd also request something called an autonomous system number. That autonomous system number is going to be the ID number provided for Miles Master Editing network. That network then becomes an autonomous system on the internet, and we're going to contract then with both TCAP and Barry to provide redundant internet access, and we will configure then BGP through routing policies to use either TCAP or Barry's ISP depending upon the circumstances. So here, if we are out on the internet and we want to reach our web server now, we can reach our web server through TCAP's ISP, and it doesn't matter where we are on the internet. The policies that we set up here for how to reach the web server are going to be based upon the contracts that we set up between TCAP and Miles Master Editing and Barry's ISP and Miles Master Editing. One of the policies we can set up is to say that TCAP's ISP is the primary ISP, send all the traffic through TCAP's ISP unless it's not available. And then when TCAP's ISP is not available for whatever reason, maybe our connection to it at Miles Master Editing goes down, then what we would do is use Barry's ISP to get to the web server. Now, that's one possible redundant internet access policy that we can create. Use TCAP's ISP under all circumstances until access to our web server via TCAP's ISP is no longer available. Then in that situation, fail everything over to Barry's ISP and pass traffic through it. Another possibility we can have here is to let TCAP's ISP and Barry's ISP figure out the best paths to devices out on the internet. And that way, if we're connecting from the purple device on the top of the internet on the right-hand side of the screen, we might use TCAP's ISP. If we're going to use the maroon device at the bottom of the internet there, what might happen then is we use Barry's ISP to get there, as that represents the best path from the maroon ISP to Miles Master Editing web server. In addition then, when we are trying to connect from our internal device out to the internet, we can use internal routing policies to either, say, send all traffic to TCAP's ISP and then out to the internet, unless TCAP's ISP is unavailable, then send all traffic from Miles Master Editing through Barry's ISP. Now, in addition, we can set up policies here that let us load balance the traffic so that we can reach our destination server out on the internet via the closest ISP to those servers, which means we could have internal routing policies on our routers inside of Miles Master Editing to allow traffic going to, let's say, the purple server there to go through TCAP's ISP, and then the traffic going to the maroon server then to go through Barry's ISP. So with BGP, we are not using BGP to calculate the best path through a system. What we're using BGP for is to implement policies between organizations connected on the internet. When an enterprise business here, like Miles Master Editing, has two internet service providers for redundant internet access, we have to take some care in how we set that up so that we can make best use of both ISPs and not end up wasting some money for our redundancy. So BGP is the solution to this redundant internet access problem that Miles Master Editing has. When we configure this, what happens now is we set up something called BGP peers. These are similar to neighbor relationships that we use in EIGRP or OSPF. The BGP peers have to be explicitly configured on our routers. There's no automatic mechanism that BGP uses to discover who else is a router out there talking BGP. So here between Miles Master Editing and TCAP's ISP, the black router and the orange router are going to be BGP peers. And then between Miles Master Editing and Barry's ISP, the blue router and the maroon router are going to be BGP peers. The policies that we set up within those devices are going to be configured by administrators both at Barry's ISP, TCAP's ISP, and Miles Master Editing. Now, the configuration for a setup like this is extremely far beyond the scope of CCNA training. What I wanted to do, though, is give you an understanding of why we would use BGP in an environment like we have with Miles Master Editing.